My name's Keith Peters. I work with Natural Resources Conservation Service since 1981 as a soil conservation technician. I'm responsible for surveying, layout, and design of grade stabilization structures, water and sediment control basins, waterways, diversions, terraces, stream crossings, wells, heavy use areas under water troughs where they install watering systems for livestock, dug ponds, earth-filled ponds, conservation tillage systems, checking residue on those. We'll also, after I do these designs, survey layout designs, we have a professional engineer that checks my design to make sure everything is correct, and any kind of support I need from them. If I have a problem with something I don't understand, how's the best way to approach something to fix it, I contact him and he comes and we'll go and look at the site together and determine what's needed to repair the problem. The practice, any practice that's installed through NRCS, through our programs that's cost shared on, has to meet NRCS specification. If it does not, they're at risk of losing their cost share. And I work with Mr. Rex Brown on installing a stream crossing on his property. And you have different types of crossings, cover crossings, which is putting in a pipe, and covering it with dirt. Also you have what they call forward crossings, where you've got a low area. You install rock in that crossing to be able to cross it. And then also other type crossings which involve bigger rock, which is riprap, and covered with top with smaller stone using geotextile.
I believe you have to pinpoint the exact location, probably using GPS to mark where the stream crossing will be.
To get the correct drainage area for the design. If you're looking at a paper copy of a topo or aerial, you could easily be 200 or 300 foot, 400 foot up or downstream, which would affect your design and the quantities in the design.
Okay, when you move up and downstream, that changes the drainage area.
It changes the drainage area.
Which means the larger drainage area, you're going to have more water coming to that point that you're crossing.
Which could require more rock, a bigger pipe if you use a cover crossing or whatever. So,
okay.
You have to look at not just the area where the crossing's going, but look at the area entering it and exiting it, to make sure that everything's, sufficient past and beyond the crossing. So, you don't just say, well, we'll just put it here and dump rock and go. You don't do that. You have to look at the whole big picture, in order to put it in the proper area.
Okay, the next step then would you take your surveying equipment and do a cross section.
What this tells you is when you do your cross section and your profile, you put your readings in and your elevations, and then you determine what your CFS is, your cubic feet per second, which is your flow. And then as you work through the design, it'll give you the elevations on each side, entrance and exit side, that crossing needs to go to in order to handle the water that's coming down through there. Okay? Yeah. These elevations here on this design, what they're showing is once you put your shots in, you work through the design, and then it's got a drawing here. It shows the elevation, the top bank on left and right bank what the elevations need to be designed to that specific height. And it also shows, you know, you set your slope, you know, your entrance and exit slope coming in and out of the crossing. You know, you can put, you know, we require a 5-to-1. Sometimes we put a flatter slope depending on, you know, what kind of equipment, if they're going to be crossing it with farm equipment. And then also in the bottom section here, which is in the stream bottom, it gives you the thickness the rock needs to be and also the width that it needs to be. It's a pretty neat, you know, design, you know, to once you work through the design, you know, when you get down here to the bottom, it's got all your distances and elevations and your slopes. It shows everything in it. And you can also give a copy of this sheet here to the landowner, so in turn, when he trades with a contractor to install the crossing, if he does so, he can give that to the contractor, and then I can explain to him, you know, what it is, and it's, when you got it in black and white there in front of you, it's more simple to understand, you know, how to install the crossing.
Okay, the advantage of this stream crossing, you don't have to worry about any beaver dams, is that correct?
No, sir. This is I like the rock crossings better than the culvert crossings simply because of that reason. There's hardly no way that they can stop this up, especially if you got, you know, a running stream. You know, it's running pretty good, because what happens is if they try to block this up or dam this up, when you get a big rain event, you got an open channel flow, and it will remove any kind of dam that they try to install in there. Versus a pipe, all they got to try to do is stop up that pipe, which is easier for them to do so. You know, you got a restricted flow there, and they can lodge stuff in there and clog it up. They can't this, you know.
So how far from the time you enter the stream crossing to exit, what kind of distance are you talking there on that?
Well, you know, all of them, like I said, are different, but you know, some of them could be as much as 60 feet, 70 feet. Some of them are as much as 40, you know, as little as 40 feet. So I have seen some of them where you needed to go at least 100 feet, you know, from one bank to the other. And that's all determined on the drainage area and the size of the stream and the flow rate and all that's involved.
Now, when you put the rock in, do you put any kind of cloth or material in before you put the rock in?
Yeah, we have to cut a subgrade. The grade that's showing on this design is your finished grade on your rock. And when we have to cut the subgrade, we use geotextile. And we use a heavy gauge geotextile. I call it filter cloth. You know, there's 2 or 3 different names for it, but it's geotextile, and we use a non-woven cloth. The reason that we use that is to you know, sediment, dirt, and stuff won't go through the cloth, and that's the whole purpose of using it. You know, sediment and dirt will go through rock. But once you put that filter cloth in and then install the rock on top of that filter cloth, you know, it'll let water through it, but it'll stop any dirt, which in turn stops any undercutting or undermining of the crossing that you got installed.